Hello, everyone. We're going to be going over Chapter 1, Section 1.2, the rule of total probability in this video. And we're going to go back to an example that we used already and is from our book, but we're going to add some layers to it. So we're still talking about a situation where we have people who are or not have a particular disease, and they either tested positive or negative for that. And you could see this as if someone had COVID-19 or not, and whether or not they got a positive or negative result. You could see this as instead of a disease state, but just a state with your body. Someone could be pregnant or not pregnant, and their test result could come up positive or negative. And there's lots more examples where this applies in biostatistics. So first, we're going to read in our data set. And remember, if we highlight our data on a PC in regular traditional R, you would just press Control R once you have it highlighted, and that will send it over to the console. But if you're in RStudio, then you're going to use Control Enter. And if you're on a Mac in RStudio, you'll press Apple Enter. So usually if you right click, it'll tell you what your keyboard shortcuts are, or you could just do traditional copy and paste. But I always suggest using a script when you're doing your code. So here we see the data has been read in. Just like the last time, we're going to reset our factors so that it's not just based on alphabetization, but it's also based on the order that we want. So we're going to set up our data set. We're going to use a new function here called dimension, and that's going to give us the dimension of our data. If we just ran dimension of data, it's going to give us the rows and then the columns. So we have two variables with 2,000 rows. But if I want to know my sample size, I just need that 2,000. So I'm going to use the square bracket 1, which says give me the first element of dimension of data. And so we see that n is equal to 2,000 now. All right. I want to create a new variable, but right now it's not so important, these groups, as this is just as an exercise in the rule of total probability. So I'm going to randomly sample using the binomial distribution. So it's either going to give me a 0, 1 for each of my patients, right, with a 0.5 probability. So I'm going to set half of my patients to be in group 0 and half of my patients to be in group 1, right? So I set my seed and I run that. And then I'm going to go one step further and say, oh, I really wanted 3 groups. So I'm going to randomly sample 500 of those patients, and I'm going to tell them that I want them to actually be in group 2. So this code will do that. And really, I'm just trying to give you guys some more tricks to be able to learn interesting functions in R, like sample.int. That will give you a random sample. Okay, so from there, if I look at table data $group, I have 3 groups, group 0, group 1, and group 2. So I've created a third variable in my data set. So if I look at the first 10 rows again, which I don't have typed in, but I'll just show you the first 10 rows, I should now have 3 variables, right? Present, positive, and then their group assignment 0, 1, or 2. So we can see that we've created that new variable. And what we're going to really focus on now is the rule of total probability, where A is having a positive test, B is having the presence of the disease, and C is the group assignment. And if you look at equation 1.6 in our book, it gives you the long equation for the rule of total probability. Don't let the notation scare you too much. I think most people actually get this formula very intuitively, which says I can find the probability of A as long as I know the probability of A given I'm in C1 times the probability of C1, right? Plus the probability of A given C2 times the probability of C2, plus the only other option is to be in that third group, probability of A given C3 times the probability of C3. So we're going to do a demonstration of equation 1.6. And so we look at first just the table, disease versus group. Okay, so we have presence and absence of disease, and then you could be in group 0, group 1, or group 2. Remember from last time that we can use the apply function to get the row sums or the column sums of any object that we would like. So the row sum of T, right, should just give us our 1,000 present disease, 1,000 absence of disease. If we look at the column sum, right, this should give us our 737, 763, and 500, as long as all goes well. Here we go, 737, 763, 500. It looks like it did exactly what we thought. So if I want the probability of A given I'm in C, right? Essentially, we want to take this 361 and divide it by 737, 381 divided by 763, and 258 and divide that by 500. But we want to automate that so that we don't have to individually accidentally type something wrong or have more work for ourselves. So we're using the square brackets here on T, and we're saying take the first row, comma, all the columns because it's missing, right? And divide that by the column sum of T. That will be the probability of A given C. So when we do that, we get each of those individual probabilities. So this is the probability of being in A given you're in group 0, the probability of being in A given you're in group 1, and the probability of A given you're in group 2. All right. So we can also just look at C, right? Which we already know. We found before in a different way, but we could also find it this way. And if we want the probability of C, we could just find the proportion table of C. So now we have the individual probabilities of C. And if we look at equation 1.6, it's saying take the probability of A given C and multiply that by the probability of C, right? So by doing that, we're going to get each of these individual terms. We should get 3 terms, and there they are. And now all we have to do is sum them up. So I'm going to use the sum function. Okay, so to find the probability of A, we get 0.5. Now, if we would have just done the proportion table of the disease status, we could have easily just gotten 0.5 and 0.5. But this whole exercise is just to show that an application of the rule of total probability. So there's always an easy way and a hard way to get the answers. We didn't need to use the rule of total probability to get the probability of A, but we've demonstrated that we could use the rule to get the probability of A. So I hope you've enjoyed this video, and I look forward to seeing you next time.